Y'all ready to be history?
Get started.
Welcome.
Hi.
Hello, everyone.
To the Pro Audio Suite.
These guys are professional. They're motivated.
With Tech to the VO stars. George Wittam, founder of Source Elements. Robert Marshall, international audio engineer. Darren Robbo Robertson and Global Voice. Andrew Peters, thanks to Tribooth. Austrian Audio, making passion heard. Source Elements. George the Tech Wittam. And Robbo and AP's international demos. To find out more about us, check theproaudiosuite.com.
Line up, ladies!
Here we go.
And this is part 2 of our talk with Michael Goodman. In this episode, we pick up where we left off and we talk about the PASsport Vo.
I like the fact that there's a restriction to the design. Like, Michael had to decide what those 6 knobs could do or not do. And so it wasn't like, oh, let's just add more knobs. Let's just make it bigger.
I did add more knobs in the black cab. It's got 9, which is kind of pushing.
You did squeeze 9 in there, yeah.
Yeah.
But no, that's the beauty of when we made the PASsport.
Exactly.
We did not add more knobs. We didn't. We forced ourselves to work within that restricted design space and say we have 6 knobs. We need to do everything we need with these 6 knobs. If there's more than 6 knobs, how do you expect an actor to understand what the heck the thing is doing as you add more and more knobs?
Yeah,
I agree.
See, we should have looked at the black cab when we were asking for stuff.
Yeah.
I have a funny feeling Michael's answer would have been the same.
I think it's an excellent way of building simplicity into it. And really also, it makes you go through the design process.
Yeah.
And I think it was a fun thing with the PASsport was exactly that. Because at first it was like so many things, add another knob, add another knob. And then you have to go through that slightly painful but sharpening process of going like, we can't only have 6 knobs. How are we really going to do this?
It's interesting. When I was younger, I geeked out a lot on the Japanese culture. Specifically, I loved their propensity for making small pieces of art, right? The whole idea with the ice sculpture. Art should be ephemeral. It should be there and it's not there anymore, right? And then the whole idea with writing a poem on a grain of rice, etc. I love compact things. And when we started making hi-fi products, we also make some headphone listening products at Centrance. I traveled to Japan a lot, and I attended these hi-fi shows, and I noticed how people are focused on completely different priorities there because apartments are very small in Japan, and therefore nobody buys a traditional stereo system with big speakers and all that. Everybody essentially listens in headphones in a tiny little spot, usually on a train on their way to work or back home. So that culture creates a necessity for smaller things. And then I kind of, for some reason, it just kind of stuck with me. I like when, essentially when you travel, you don't want to lug around a 19-inch rack or even like a 500 series lunchbox things. That's the way we're trying to make these things small. But getting back to PASsport Vo, that had the restriction there was basically the same one that was popularized by Henry Ford, who said that you can have your Model T in any color as long as it's black.
Yeah.
And then so basically we have this we have this box, and whatever you want to have must fit in the box,
which was good, and it was an interesting exercise. Me being the guinea pig who potentially is going to be the person who uses this thing. And I didn't want it too technical, so it was and trying to get the terminology something that people like me would understand. So that was an interesting exercise for all of us as well.
There was a lot of pushing and pulling between the Andrew Robert hemispheres of the design team.
There was.
Yes, that's right.
Yes.
Well, I was wanting to keep it flexible and let it do more things, be both for instance, I wanted it to be the interface that you could take on the road or leave in your control room and run it as your whole studio interface, or have it in your booth. And it could work in any place. And Andrew was like, I just want to travel with this thing.
It was kind of interesting because it was that we were the polar opposites. So you had, Robert on one side, me on the other side, and George and Robbo in the middle. George particularly trying to make sense of our nonsensical.
And the filter, and I was trying to condense down everything what they wanted to
George was the
convey it
traffic
to
cop.
Michael, so that Michael didn't end up having to be the traffic cop. It got out of control at one point. The thread did expand at one point. I remember distinctly.
Yes.
And I was like, wait, no, I'm supposed to be protecting Michael.
I think that was important, giving Michael one point of communication, because it would have been maddening for him.
Exactly.
Well, I have to say, I actually enjoyed the process. I mean, there was a lot of creativity in ideation throughout the whole thing. And if you have, I love ideation myself, so I'm not really necessarily opposed to it, as long as it eventually comes to a solid, well-defined feature set, which I think we have. So that whole process, that worked very well for me, and I do appreciate, George coming in as a traffic cop and essentially directing a lot of that traffic.
And an architect as well, can I just say, with all the drawings that he had to do.
Well, I had fun trying to figure out a way to draw a signal flow diagram, which I'd never really done anything. And I know there's proper nomenclature and symbolism and all sorts of stuff in drawing one. I didn't know that, so I just did my own thing. But it really was cool because it helped me tremendously understand what goes to what. And we revised that signal flow diagram, I don't know, 7 or 8 times probably.
Probably a lot more.
Oh, yeah.
A million times.
I think it was the blend of having the signal flow diagram so you could really see what was exactly going to happen, combined with the mock-up of the final device.
Yeah.
So you could get an imagination of how it was really going to work in the field.
Yeah.
And I think we really came up with something that fits Centrance in the sense that it fits obviously the form factor, but it's super flexible and unique. You're not finding this in any other interface.
No, I think it'll continue to be unique because it is so purpose-built that other manufacturers will look at it and go, why?
That's right.
Exactly.
Because there's nothing else out there that's been purpose-built for voiceover artists. I think that was the initial motivation. Was for years, voiceover artists have had to take stuff that's built for music engineers and rework it to make it for voiceover.
And it seems like this is such a niche industry that, a larger manufacturer, might not necessarily see a lot of business potential there. So I think that was a good match between our size being a smaller company and then a market being smaller that we were like, okay, that makes sense.
I think you see that in its price point.
Yeah.
Someone who's looking at it really basically goes, I can get a 2-channel USB interface, 2 microphones USB interface for $100.
No, this is not that.
And it's like, if you see that in there, then you're not seeing what this is.
Yeah.
At all.
It's not for you. There's almost like when you set something at a price point, you're trying to give a very clear, not only you're saying that it's worth it, obviously, but you're making a very clear statement that this is priced for professionals. And it's worth every penny to a professional who will understand the value. And we've already had people stand up and say, I believe it. I see what you're saying. And they've blunked down the cash.
Yeah.
And let's be honest, for a working voiceover professional, not everybody, of course, but a lot of those guys can make that much money in 15 seconds.
Pays for itself in one gig.
That is true.
Yeah, exactly.
So we knew that pricing was going to be tricky, but we also knew that we had a restricted space in which we had to work. We can't, we wanted the value to be there, but we also have to make a profit. Michael has to make a profit. And we had ideas that would have driven the price even higher, quite a bit that, we could have implemented, but we didn't want to do that. There's a certain point where we thought, let's keep it under that.
Well, I remember one was how we handled and this is actually something I have a question with the English channel. Like, we wanted to make the PASsport flexible enough to use an external preamp instead of the built-in one. And I know that was important to Andrew. And one of the things I find with the English channel is that when you come out line level XLR and you go into the Courtcaster, turning the Courtcaster down is not enough. You got to pad the other stages beforehand to get it, because you're kind of feeding a mic pre into a mic pre. And I remember that was one of the things where we had to accept that we were going to go through that chip, if I remember right, and we didn't get a pure bypass of the mic.
Right, because that was going to raise the parts count and the cost in other ways. And it was such
because of the switching.
It was something where it was going to add cost to make a very small percentage of users.
It would not have made a difference to most users.
But even based on that, I have to say that if you look at the new Neumann interface,
how much is that thing? Like $1,200, right?
Well,
no, more than that. Well, it will be like over 2,000 US.
18 from what I understand.
18.
Yeah.
I'm sorry, and it doesn't do as much as the...
And also, when you're talking about having, bypassing the internal preamp, it doesn't.
Oh, really?
It doesn't. Like, nowhere on that new Neumann interface can you bypass a preamp.
Fascinating.
I would wonder if that's a subject of pride, We give you the best preamp in the land. Why would you want to bypass that?
I would suggest that would be the case. Yeah.
Well, the irony is that they sell a preamp. Like, they sell a very expensive preamp. Outboard preamp, so you would think that they would have that.
Do you want to know what device that is? It's the reincarnation. It's the perennial. It's like a locust that comes out of the ground every 8 years.
Yeah.
And the last one that emerged out of the ground was the Mini-Me.
The Mini-Me from Apogee.
The Apogee Mini-Me. Yeah. Badass preamp, badass converter.
Yeah, and soft clipping. It had that limiter.
But really expensive interface that's just going to, I'm expensive, I'm going to be the best kind of thing is what it's trying to be. But it's not flexible.
Mini-Me is not a convincing name.
No, I know,
it's
the
not,
Mini-Me.
really.
Well, if that movie hadn't come
The
out,
Mini-Me? Yeah.
I'm sure.
Yeah.
I'm sure when that movie came out.
But really, the Mini-Me is a kind of, it wants to be the original AD1000, which I have several of those, and those are great.
Yeah, but they don't use FireWire or USB, right?
The Mini-Me, I believe, is USB.
Are you sure? I don't think so.
I'm pretty sure. It runs as USB and a separate preamp.
But I don't think it has any protocol. See, that's the thing. Like, as soon as you add a protocol to the unit, like a USB protocol, a FireWire protocol, you're now dating your product. It is now locked in time. It's now going to be obsolete at some point.
Correct.
Like this happened in FireWire. Actually, FireWire just became officially obsolete with, I think, Ventura. If you have a FireWire device.
So even if you have like a FireWire to Thunderbolt adapter, it doesn't matter.
They dropped off the protocol. It's gone. Poof.
Well, the lightning jack is about to go the way of the dodo.
Yes, that's right. And
Oh, really?
Because of Europe.
Thanks,
that's a whole
Europe.
other can of worms, right, Michael? Because I know you spent a long time dealing with the lightning port and the, what's it called? Made for Apple, MFI.
MFI. Made for iPhone.
Right, made for iPhone. And wasn't that like a major stumbling block to getting the first mixer face built and designed?
Correct. We started down that path in our hi-fi devices because we wanted to make these headphone amplifiers that plugged into the phone, because a lot of people started moving their music collection onto the phone and using the phone as the playback device.
Right.
And then that kind of translated into recording products as well. So Apple decided to keep that, walled garden ecosystem all to themselves, and then as a manufacturer making a peripheral device, a product that would interface with the Apple iPhone, iPad, etc., you had to go through a lengthy bureaucratic process to establish yourself as a registered developer, essentially, in the MFI ecosystem. And they policed that hard to the point, it got ridiculous. So the lightning jack actually is quite sophisticated. There's a chip inside, and that chip has a serial number, a laser etched serial number inside. So every lightning jack in the world has a unique serial number, believe it or not. This information is less relevant now, but it used to be relevant before. So what had happened is if there was a cable, a lightning cable, lightning to USB, that was not made per spec, any cable that you made as an MFI manufacturer had to be certified by an Apple-approved lab, and it had to do all of the things that a lightning cable had to do.
It was very annoying when they started enforcing
They enforced it all the time. And then what they ended up doing is there's been a plethora of Chinese cables that were not approved. So Apple was able, because they actually had control over the chips inside of the lightning jacks, they were able to remotely disable cables.
Wow.
And then we'd get we still get these calls. It's like, man, I plugged this lightning to USB cable into your product, and it doesn't pass audio. It's your product. No, it's the cable. That cable just hasn't paid the fee. And by the way, you had to pay the fee to Apple if you were an MFI developer. The manufacturer of that cable either didn't pass the test or didn't pay the fee or whatever, and their cable had been remotely disabled.
Yeah.
Wow.
Which is bizarre. But that went on for a while. And after a while, we were like, we're too small to be able to deal with this because there were like constant updates.
So then you just have to get your own interface adapter. So you couldn't plug straight into the phone anymore. You had to have some stupid dongle so Apple could get their fee.
They got their fee one way or another. But now, with thanks to Europe, it's just going to be USB-C, and that whole Lightning adapter is no more.
Oh, so let me ask you this. Is the MFI certification, whatever you want to call it, is that now dead because of USB-C, or is it still in there somewhere?
There is no special communication happening anymore because USB-C is supposed to be generic, and you had to announce yourself and you had to be in the database, and that's how they tracked you, essentially. But now there is no communication there. And then so now it's just like a Windows machine. You plug a peripheral, a USB peripheral, into a Windows machine, and if it's a generic peripheral, it pulls up a generic driver and knows what to do, knows how to work with it. With Mac, it's been like that forever, and they've written great drivers, a lot better than Windows, so that any audio interface you plug it into a Mac, it works right away.
Yeah, as long as it's a core, what do they call it, compliant or core audio compliant?
Core audio.
Right.
Core audio compliant. Yeah.
Right, exactly. And then so it's going to be exactly like that with the iPhone and iPad. It's been like that with the iPad for about a year now. So just one less hurdle to jump over, which...
That's progress.
Yes, and that's good. Because we had this conversation the other day when you were coaching me on how to make the proper connections here. And I was pulling my hair out trying to get things working. And I realized that it works in this environment, not in that environment, and all that.
Oh my gosh. Honestly, when I was writing that, I started doing I went down the rat hole on the developer page of Apple, right, to understand better how the iOS audio AV, system works. And it was like there was 7 distinctly different and unique modes of operation.
Because it's trying to make all these decisions for you. It's like, can we interrupt this phone call? Can we interrupt this movie, right?
Right. Oh my gosh, it is so complicated.
It is pretty annoying.
It's all complicated on the developer side so that you, the user, don't have to think about it. But they make those decisions for you, and that's what runs us into trouble as pros. I wish, again, because of iPhone 15 Pro and the new chipset, maybe this is going to change. But I wish we could really control our devices, and say, I want to use this as the input. I want to use that as the output. I want to send this over here.
On the Windows side, there is this protocol that's been around for a while called ASIO. ASIO is the one that is direct to device, and it was developed that way a long time ago. So that
it was made by Steinberg.
Yeah, and that would not be interrupted if you're playing a YouTube video or a phone call comes in. Your session continues to be solid.
Right.
Nowadays,
The problem with ASIO is that it can't share very well.
The whole point of it is that you shouldn't share.
Yeah.
It should be like point to point, indestructible. You know what I mean?
On the Mac OS, it's got it with Core Audio where it shares it just fluidly, and the only thing that you have to make sure of, which is the same with any situation, is you just keep, if I'm sharing it, we have to agree on what sample rate we're going to be at. The device can't be at more than one sample rate.
But there's still weird stuff on the Apple side where, is the volume up and down button on the keyboard going to change the output level of my device?
Exactly.
I don't know. Is the input gain setting on Mac OS going to be effective on the input level, or would that be...
If that device is set as the output in system preferences, then your knob becomes a control if that device is controllable. Not all devices are controllable, and you'll see that some of them, if you select them as the output, the slider becomes grayed out.
But who decides that? The manufacturer of the device, the writer of the driver, or the Mac audio stack or whatever?
That's the device.
In reality, it's everything. It's a little bit of both. So some decisions Apple has to make, some decisions manufacturer tries to make, but then Apple could reverse those decisions
right.
at their own volition. Anytime you have a competition between a whole bunch of sound sources, like phone, movie playing, another movie playing in this other window, and then your audio thing. The system has to decide what's the priority, which of these programs really has to be streamed, and which other ones have to be muted, or do you want to just mix everything together, which is kind of madness, right?
Yeah. iPhone does some weird stuff. Like I know we're going down a rat hole.
It's very useful. It's like the way a Nexus device works. You can they're like patch cables, and if you send two devices to go out the same patch cable, it just mixes everything together. The Wasapi Windows driver is a little bit more flexible and a little bit more core audio like than ASIO.
It mixes everything. And they worked hard on doing that. Here's a problem. Because it has to mix so many different streams, again, from these movies and radio stations and everything else that you could be listening to and watching at the same time in the same Windows computer, what they do is they have to align the sample rates from all these different sources. The process of aligning the sample rates results in a delay and latency. So that's completely inapplicable to music recording. Rob, you would know about that. And then if you're watching a movie and the sound comes in 30 milliseconds later, you don't know it. It's just, it doesn't matter. If you're recording music and sound comes back 30 milliseconds later, it ruins the take.
So I wonder if the latency in Wasapi is similar to the latency in core audio, because anything that's native, every audio engineer knows it's more.
It's a lot more in Wasapi. Core audio is just very, very well tuned.
It's like Wasapi and fast. It's like Wasapi and ASIO combined in a way.
Wasapi generally introduces delay, and it introduces a lot of convenience at the price of the delay. Whereas ASIO is as little delay as you can have, so essentially the delay through the computer is about 2 milliseconds each way, and then the rest of it is the interface. And then, but it's point to point. There are no decisions to make, so there's no pausing to think whether we should do it this way or that way. That's the beauty of ASIO, and core audio is very much like that.
Since we're talking about Windows a little bit, is it too early for you to tell us, Michael, when you connect the PASsport Vo with its two USB buses or two USB interfaces to a PC, is the best choice for the user in most cases going to be, what do they call it, MME or Windows Classic WaveDriver or Direct Sound? Or what's going to be the optimal setting, do you think?
Wasapi usually is the best if you know what you're doing and you're not sending several different streams into your interface, right?
Right. And you won't be, because with this design, each USB bus is basically a simple 2-in, 2-out
exactly
interface, right? So you're the hardware, it's all that mixing that we try to do with software and sometimes not very successfully is being handled in the analog domain or internally inside the unit, right? So we don't have to even worry about that anymore.
That was a very smart idea or path.
Oh, that's the beauty of it. No drivers, nothing to install.
That's the goal.
That's the plug and play.
Yeah, you could have two separate applications running at the same time. One could be, sharing applications such as Source Connect. The other one can be a recording application, right, such as a DAW, a local DAW. And then
Adobe Audition's a popular choice on Windows.
Those applications could actually meet inside of the device, inside of PASsport Vo, and not really conflict with each other as they would be if you were trying to mix inside the machine.
Yeah.
This is why we did it, because on Windows, this ability to have two applications use the same device at the same time can cause huge tech support issues. Huge. And one approach is to basically have someone like George help you out and figure it out, going into drivers and turn them off of exclusive mode and things like that, and then crossing your fingers that it works. Or
no, I have Mike McGonigal do that. I won't touch that stuff anymore on Windows.
Or just do it this way and dedicate one interface to one application, the other interface to the other, and then do all your cross-patching and your blending in the analog domain with.
That's unique. Nobody else does that, right?
And that internally, Michael, just to make that really clear, it's an analog signal path internally, right? Like that's all. It's staying completely analog.
Yes, it's an analog mixer which has two inputs which happen to be digital streams from the computer.
But they've been converted from digital to analog.
To analog and become analog. Mixing in analog introduces zero latency.
Right.
It's the that old technology. We're going back to the British invasion, and it's seamless. Essentially, there are no conflicts when you're mixing in analog.
Yeah, no sample rates to coordinate.
George, it's a bit like when you use the Behringer interface to plug externally back into someone else's interface.
As a problem solver.
It's that, but it's all in the box with knobs and switches to control it instead of...
Like you could have your DAW running at 2496, maybe 24-bit 96, and you can have your Zoom or Source Connect running at whatever the heck the client wants sample rate it needs to be. And they will not step on each other's toes at all. You don't have to worry about that.
Yeah, that's completely transparent in the analog domain. So I think that was a brilliant move.
I can't wait. That's such a cool thing. Yeah.
Hey, listen, I can't wait either. So a small development on that front. I know everybody wants to know status. We are, as I mentioned before, we have 3 separate paths here, and we're about to choose one. With regards to the actual USB chip. So I've laid out all of the analog circuitry. It's already done. So all that mixing that we've just talked about, that's all already in the design.
Cool.
It's designed and it's waiting to be prototyped. I am pausing and not sending this to prototyping because there's one additional block that needs to be finalized, and that block is the USB portion of the design. Actually, there's 2 USB portions of the design because, as we just said, there's 2 USB ports and there's 2 different computers that you could connect this thing to at the same time, and then you would then blend between the signals from those 2 computers. So for the USB chip that goes inside of there, the 2 USB chips, we learned recently, unfortunately, that the chip that we've been using for like 12 years or so is now out of production. And the manufacturer does have a newer version, but it's larger and more expensive. But the larger part is more important here because, yes, we do have that small box and it just wouldn't fit. So we started a big search for another chip. And we found a manufacturer in Taiwan, which is a smaller manufacturer, and it makes a chip that is smaller also. And that seems to fit the bill, but it's we wanted to make sure, we kind of wanted to vet them, It's just,
yeah. You don't just slap any random chip in there and hope for the best.
Yeah. Well, it's like a couple of guys in an office. Are you going to be around next year?
Yeah.
So I have a friend in Taiwan who visited them yesterday and sent me a lengthy email. Anyway, so he visited them. He lives in a neighboring city. It's an hour drive for him, not that big a deal. So he popped over and he had a meeting, and he said it was a very pleasant conversation. They use Taiwan is where they make all of the chips pretty much in the world these days. So they use a couple of foundries, a plant that makes chips. And then so they use 2 very reputable suppliers for that, and everything is well tested. I was like, do they test these things? How's the reliability? Do they have any large customers? Turns out this company is not well known in America, in the West yet, but they are known in China, and they're shipping significant volume into China. So I think there's the reason to believe that it's going to be a reliable supplier. And so my friend there in Taiwan, who actually works for a large contract manufacturer, is like, yeah, you should go ahead and work with them. Not a problem. I don't see a problem.
Milestone moment right here, folks.
It just happened yesterday, as a matter of fact. So we're like, oh, okay, well then, thank you. So we're not, concerned about their longevity and all that. So there was also a third path, which was, there's still a stock available of the old chip that's gone out of production, and we can put that in there, but that would just kind of be a step backwards, putting something in the product that is not going to be made anymore.
Yeah.
Are there any features on the new chip, like it goes up to 384 or
it does
your taxes?
It does do your taxes. That would be important, but the 384 I think less so, because I'm joking, of course, because who needs 384 in real life? Audiophiles love their 384, except there's no content to play. But you got to buy your DAC.
It's the album of mouse farts.
To each his own.
Yeah.
So, and one other thing I want to touch on before we wrap it is I also know that you have invested in a rapid prototype, or what would you call it? A prototyping?
You can make your
machine?
own boards now, right?
It's a pick and place machine. That's the official name.
Pick and place. Gotcha.
Yeah, electronic components these days don't go through little holes in the side of the PC board. Instead, they're just they're planar. Yeah, they're just put on the surface. And some of these components are smaller than 1 millimeter by 1 millimeter. They're really tiny.
Yeah.
And then it used to be 10 years ago that they're larger, maybe 3, 4, or 5 millimeters. You can actually use tweezers and just put them on the board yourself. It'd take forever, but you could do it.
Right.
And then you'd put this whole board with all these components that you just very carefully put on the board, and you would put it inside of an oven and heat it up for about 10 minutes. There'd be a particular heat profile, and that would solidify all of the solder and connect all the components together. And after you had a board, for prototyping, that was a thing to do. Nowadays, components are so small that even if you have a magnifying glass, it's just, if you partied the night before, your hand is not as steady anymore. So therefore, assembling these things, and I'm not saying that people should not party, but it kind of puts a cramp in your style. Anyway, so this automated pick and place machine that we have now, it does that for you. It's a robot, and it just kind of it has a tiny little suction cup at the end of a needle. So it just moves over the hand moves over to where you have your components on a reel. They're not like a bobbin, this is reel. And then just picks one up by applying a little bit of suction, kind of sucks it out of the reel, and then moves it to an appropriate place on the board and just kind of releases gently. And it can handle things that a human hand cannot handle. So from that standpoint, it's a huge benefit, and it actually does it fast, and it doesn't party the night before. From what I know,
it doesn't ask for raises, and it doesn't.
Yeah.
So I have so many questions. I mean, I'm dying to see one of these working in action. I'm sure I could probably find one on YouTube. But how long does it take to populate a board that would go inside the mixer phase or broadcaster?
About 10 minutes at this point.
Wow,
whereas
that's
if you do it
amazing.
by hand, you're probably at it for a couple hours.
Oh my gosh, yeah.
Yeah.
And you're developing cramps.
When does it get to the point where it's just by order? When does it get to the point where you can make your board, you can assemble your board, you've got a 3D printer? Because I really like the case for the English channel. A lot of manufacturing is okay, we're going to make a product, and then there you have 60,000 of some plastic thing. And then maybe they sell, maybe they don't, and you just have a lot of extra waste,
Been there, done that.
And here's making these things as needed, right?
The 3D printing, yeah, we make everything for order, and we've been sheepish about it for a while until we got to the point where we figured out how to make it look good. And also make it reliable so it doesn't break. So these 3D printed parts at this point are completely usable. I mean, they're not toys anymore. They're functional pieces of mechanical design. And we love that because we can change colors. You can get this, the tray, the commander console, we call it. For the English channel, you can get it in lime, lemon, red, blue, white, black, whatever, gray. So, and this is so easy for us to do. We don't, otherwise we would have to order, thousands of each color and then store them somewhere. And now it's just, we just have these reels of filament, which is this, it's just essentially plastic out of which everything's being made. And then we can make them to order. So that's really great. And then as far as how long does it take? Well, the box that we make everything in is still aluminum. So that box, fortunately for us, we make a lot of different products inside the same box. So we can order it by a boatload from the manufacturer because there is a minimum order quantity. But we figured that, we will go through the entire order because we will put different products in that same box. And that way we can afford to buy a whole bunch at once.
So one more, the board thing is amazing. so after you've dropped tiny, tiny little components over this little board, so is that the point where it goes into the oven? And how do you keep the little tiny, tiny, tiny pieces from moving around?
You squeeze solder paste, the official name. You squeeze a layer of this gooey, it's just like toothpaste, but it's dark gray.
Yeah.
And it has the property that when you heat it up, it solidifies and it becomes metal. So, but basically you get a stencil, which is this thin metal plate, steel plate, very thin, less than a millimeter. And then holes for the components are laser cut inside that steel plate. And then you put that steel plate over the board, line it up correctly, and then you use a squeegee to essentially squeeze that paste over the stencil. And then where the stencil has the holes, the paste drops through the holes onto the PC board and then forms the tiny little squares in appropriate places. Then they're a little sticky, just like toothpaste. And then when a component drops onto these two squares, for example, if a component has 2 pins, right, it kind of gets stuck in the paste, and it doesn't move. And then you can handle the board. I mean, you don't want to throw the board because the components will fly off. But if you carefully handle it and carefully move it into the oven, then the components will not move. And then what actually happens in the oven is a beautiful thing due to surface tension. Essentially, the components, once they heat up, they line up because the tiny little solder balls. So essentially, you have liquid metal. At that point, if you remember the movie Terminator, there was this other Terminator guy that was essentially made out of liquid metal, and he could reassemble himself at all points. Remember that?
Oh yeah, T2.
Yeah. So like that's liquid tension. Is like when liquid gets together, it just forms this one thing.
Wants to make a ball.
And that is what allows these tiny little components to get soldered to the pads in a very even, sort of a glowing pattern where all the solder gets utilized and none of it is left around, because it all kind of tenses up and kind of sort of sucks into one bowl in each little pad.
That's cool, man. Thanks for describing that. That's really neat.
Michael, I actually had one quick question. With the faces, can you cut your own faces right now?
When you say faces, what are you referring to?
Like all your pieces are made out of the same metal, sort of 2 pieces of metal.
Oh, I understand.
And right now, they always have the same 4 outside screw holes to hold them together, but then on the top of it, there's different holes for different knobs. Mm-hmm. And what I'm asking is, do you need to make 7 holes in this one, 3 slots for a different switch, and you're able to do that all at your place now? I mean, could you theoretically just...
No, we still do it at a supplier, but good question, yes. So the official term for this is platform strategy, is when you can make a lot of different things out of one thing. Another official term, if you want to keep going with the MBA speak, design for postponement is what we're using here, if you want to be official about it, which means that you can make the decision on what the heck it is that you're building at the very last step. Right, which also allows 3D printing is the same thing, right? You postpone the differentiation of the product, and then you can actually choose what you're building the day when you ship that thing, right? Toyota has pioneered that in the 80s, with the whole just-in-time strategy and all that, and because they were able to reduce the amount of stuff that they held at their warehouses, which were huge. Anyway, so what happens with these products is, on top of the product is this plastic overlay. It's actually a sticky, it's a sticker. Yeah, it's a thick sticker made out of polycarbonate. It's a polycarbonate overlay with an adhesive backing that we very carefully lay in this, existing hole. And then that sticker we print. And then fortunately we have a supplier who doesn't want us to print thousands of them. They can print 100 at a time, and then those stickers themselves are not that expensive, and that therefore we can get 100 stickers of each product, and then essentially put the sticker on the product the day we assemble the product and the day we ship it to the customer, which allows us to be a lot more flexible than a traditional manufacturing plant.
So then if you have the ability to drill your own holes and slots at some point, whatever CNC machine that is,
we have that.
There you go. You do? Oh,
yeah,
well then.
Yeah.
There you go.
I haven't let you into the warehouse yet. You should come back.
I'd love to.
Yeah.
He's on his way.
Yeah.
Yeah, he's leaving now.
And on that note, as Andrew would say.
Yes.
Well, that was fun. Is it over?
The Pro Audio Suite, with thanks to TriMove and Austrian Audio, recorded using Source Connect, edited by Andrew Peters and mixed by Robbo. Got your own audio issues? Just ask Robbo.com. With tech support from George the Tech Wittam. Don't forget to subscribe to the show and join in the conversation on our Facebook group. To leave a comment, suggest a topic, or just say g'day, drop us a note at our website, theproaudiosuite.com.